Section 5.6 is on finding all real zeros of a polynomial function. Now we've dealt with zeros before when we were working with quadratics, and remember that a solution, a zero, or an x-intercept are all the same thing. We can use these words interchangeably. So in our quadratic section we got something like x squared plus 4x minus 12, and we were asked to find the solution or the zero or the x-intercept. And to do that you would just solve this. So we factored it first, and then set each piece equal to 0, and got that x is -6 and x is 2. Now we know that those are the two solutions or the x-intercepts where it crosses the x-axis, or the two zeros, all the same thing. So you're going to be doing that with polynomials, except polynomials have a greater degree than just 2. We could have something like f of x equals x to the 5th plus 4x to the 3rd plus x minus 7. Well, we can't factor that, and maybe the methods that we just learned in the previous section don't allow us to factor this. So what we're going to do is we're going to find all the possible zeros or all the possible roots. Also the same thing, we can add that to the list of our interchangeable words, roots. That's what we're looking for. So if a polynomial is written as f of x, so for example right here, f of x, and it has integer coefficients, then every possible rational zero is going to be written in this form right here, p over q. P is the factors of the constant term, so you're going to take the factors of the constant term and divide them by q, which is the factors of the leading coefficient. So we're going to divide it by the factors of our leading coefficient over here. This is going to give us a list of the possible zeros, not all of them, just the possible ones. And we're going to use a graphing calculator to narrow down our search for all the feasible roots, because this isn't all the roots, it's just all the possible ones. So there could be a lot. Let's look at an example. Find all the rational roots, the possible roots, of this function right here. So what we're going to do is find p over q, and remember that p is the factors of the constant and q is the factors of the coefficient. So listing the factors of the constant, our constant is 12. So listing the factors of 12, we have 1, 2, 3, 4, 6, and 12. Those are all the factors of 12. But also we have the negatives too. This could be plus or minus 1, a plus or minus 2. So these are all plus or minus, because it could be positive or negative. Then divide this by q. So divided by all the factors of the leading coefficient, where our leading coefficient here is just a 1. So you would divide all these by 1s, and you don't need to write that. You don't have to divide all this by 1, because it's just going to be the integer. So we can just leave it as plus or minus 1, 2, 3, 4, 6, and 12. So these are a lot of possible roots. And I don't want to try and divide this, all of these options, into this polynomial. So what we can do is look at the graph. So if we were to graph this, this is what the graph looks like. And we can see that maybe it crosses at -4, a -1, and maybe a 3. So I'm going to try those. Instead of trying some random one, I can use the graph to narrow it down to see, well, where does it look like it's crossing? Now I can't just say, oh, it's 3 because it looks like the graph is crossing there. We're not for sure. When we get a lot of different fractions and things in our possible list of zeros or possible list of roots, this could be a fraction and not a perfect integer. We're not for sure, so we have to test it. So what we're going to do is use synthetic division. So I'm going to pick one of these. I'm going to go with -1, just for the heck of it, and set up my synthetic division. So use your coefficients from up here, the polynomial. We have a 1, and then a 2, a negative 11, and a negative 12. So I bring down my 1, multiply. Remember, you're always adding these two lines. Now, remember in the previous section we talked about if you synthetically divide and you get a remainder of 0, that means that the number you divided by is a root slash solution slash 0. So that means since we divided by negative 1 and we got a remainder of 0, this is a solution to the graph. So we're going to remember that and finish our synthetic division. What we have left over, remember when you synthetically divide, you go down a degree. So we were at degree 3. So that means here this 1 is an x squared plus x minus 12. This negative 1 is a factor of x plus 1. Because if we set x plus 1 equal to 0, we would get negative 1. So we have our factor of x plus 1. We need to continue factoring this. There's a couple different ways you can do that. You can choose another possible 0, so either negative 4 or 3, and divide it into this x squared. But it's a quadratic. Double check to see if it factors, because it probably does. Factors of 12 that subtract to give you 1. Well, I can think of a couple. How about 3 and 4? And we'll have a positive 4 and a negative 3 because we have to get to a positive 1 in the middle. So now this is completely factored. To find the zeros, just set each one of these equal to 0. We already did it for the negative 1. We already know that's going to be negative 1. Here, if we set these equal to 0, we get negative 4 and 3. So these are the zeros of our polynomial, which we can see in the graph. So what I want you to do is for this polynomial, I want you to list all the possible roots.